Welcome to another episode of the Student Spotlight series, where we showcase some of the work our past students have done. It is our pleasure to have with us Yousef Haddad. So, Yousef, can you tell us a bit about yourself, where you're from, what year of school you're in, and what course you took with CCIR?
Yeah, so my name is Yousef. I'm in my senior year of high school. I'm from the Seattle area, and I did the one-on-one research mentorship program at TCIR for 14 weeks, and I worked on a research paper with a faculty mentor at the University of Cambridge.
Okay. Can you say who your mentor was?
Yeah, so Dr. Alejandro Carnicero Limbarte was my mentor. He used to work at Cambridge while I was working with him. Now I think he's moved to Hong Kong to join a separate research team.
Okay, cool. So, how did you become interested in the program?
Yeah, so I was looking for summer programs. I had passion for neuroscience and the intersection of neuroscience and AI, figuring out how to combine like engineering with AI and getting the physical systems of neuroscience. And I wanted to explore that more. And then CCIR offered a one-on-one research program where I could match up with a mentor who's currently doing that in the field. So I think CCIR stood out to me because it was an opportunity for me to get practical applications and also learn about, neural systems and how it combines with AI.
Mhm. So, can you say a little bit more about what your research topic ended up being?
Yeah, so our research topic aimed to fix this problem in the lab. So at the University of Cambridge Bioelectronics Lab, they had a brain-computer interface, and they were testing it on rats. So basically, they had an interface with 12 electrodes around a rat's nerve below the spine, which was measuring the electricity levels in the rat, and they could map, the different signals to whether the rat was walking, peeing, and this was like used with the idea of later being used for humans in the future on brain-computer interfaces that could, help injured people and with building prosthetics to help those paralyzed people. But the issue that they had was that this doesn't scale for different rats because, the specific positions in which they place electrodes is different for each rat. So let's say electrode one was giving like the signal for walking in the rat. Like it wasn't the same electrode one in both rats that were given the same signal for walking. So the problem was translation across rats. And the issue that I aimed to figure out with my mentor was how can we take our data that we have of the rats and try to combine it and forget about the specific electro numberings so that we can make a better translation and work with more data across rats so we can get better translation results.
Okay, cool. Yeah, that sounds extremely interesting. So to clarify, I guess this brain, computer interface was something that the lab at Cambridge had already developed, and then
Yeah,
you, I guess, identified with your mentor this problem that they were encountering and tried to do research related to that.
yeah, exactly. My mentor was super helpful and very knowledgeable in the subject because he works in the lab and he was able to identify a problem that he had in the lab that people weren't working on, and that's what we aim to solve together. And that would help, later be used in the lab's operations.
Okay, cool. So what were the main takeaways at the end? Did you have like a kind of clear hypothesis that you were testing, or what was, I guess, what insights did you come away with?
Yeah, so it was actually really interesting. And our what we did was, we forgot about the electro numberings and we instead just pulled all of our data together from multiple rats. And we found that this helped actually our predictive power of our model. And once we took like three rats data combined together, it actually increased our accuracy and the model was able to properly translate like, okay, this is the walking, this is when the walking is active, and this is when the bladder is active, even when the electrodes were different because we, scrap the electro numbering system. But when we added too many rats, like once we scaled to like 10, the model became confused even more and our accuracy dipped. So we kind of had an upside down U shape where, from the number of rats going from 1 to 3, it was increasing, but if we went too far, the predicted like accuracy would go down once we added too many rats. So that was a kind of an interesting takeaway. Like we knew it was important to pool our data together, like because more data would help the model learn better, but you know, diminishing returns and actually hurt the model even more once we added more rats. So that was pretty interesting.
Do you feel like the diminishing returns that you experienced when you added more data call into question at all the conclusions that you reached with the smaller data set?
Yeah, we had a hypothesis about this because we knew that it would confuse the model more once we add more rats because like each rat had different um, spikes of like electrode activity at different times. So once we add more rats, the model will be like, okay, what am I supposed to do with all these spikes? So it was actually really interesting that we saw the increase from 1 to 3, but it was more expected that we saw the decrease from 3 to 10 because of how many spikes and all the times that, was kind of confusing the model.
So, I guess what would this say about the, I guess, big picture applicability of the model that you built? Do you think that the smaller data you're actually getting, I guess the question I'm trying to ask is, do you think that the increase in accuracy you experience with the smaller data set is usable at scale, or do you think that the fact that when you added more data, you lost accuracy indicates that you might have to change your approach?
Yeah, so it actually helped that we pulled the data from 3 rats combined. So this actually indicates that, when we want to use this technology for humans, it's helpful to pool the data to some extent. But like the 10 rat experiment showed us that if we went too far and pulled the data from too many subjects, like the subjects were so different that it confused the model too much. So having like a good amount. Like three was our like Goldilocks temperature of how many subjects we had or how much data we had for the model to have enough data to learn proper patterns when the electrode timings are scrambled, but was not too much for the model and like having random spikes at random times. So like the 3 was our sweet spot. I think that when this can, be used for humans in the future, having like a pool of data from multiple subjects, but not too many, I think is the methodology that we want our like that we learn works for our models.
So, just out of curiosity, what kind of secondary literature were you engaging with in this? I mean, I guess where does this fall into, I guess, existing research on the topic?
Yeah, so my mentor actually provided me a lot of like archive papers. He helped me like locate, what the lab was doing. And honestly, most of it was not reading secondary papers, but actually like telling me, okay, this is how the lab, like the Cambridge Bioelectronics lab, aimed to fix this, and what went wrong, and how can we like work around that. But there were obviously like a lot of times where I wanted to solve very specific problems, and we both looked at archive links and scrolled through that to find papers tackling the same thing. But mostly it was he was telling me what was going on with the Cambridge Bioelectronics lab and what went wrong for them and how we can, fix that, or what worked for them and how we can emulate that.
So then, how did you end up differentiating your approach, I guess, from previous attempts by the lab at Cambridge to address this problem?
Yeah, so the lab at Cambridge didn't really go in depth. This was kind of like a problem that they had on the side, and like my mentor was telling me like this was just like a thorn in their side that they had been dealing with for a while. So that was like the appeal of the problem was that like people didn't really attempt to solve it in depth before, especially because this brain computer interface, like this technology with the electrodes around the nerve, was something like only the Cambridge Bioelectronics lab had at the time. So it was really interesting, for us to solve this problem that no one had solved before, but also, getting information from the lab, like, okay, so this is the issue when we tried this. So that was kind of our main goal there.
So you mentioned that I guess your interest in the program came from a prior interest in the intersection between neuroscience and AI. Am I remembering that correctly?
Yeah, yeah.
So what do you think maybe some future projects that you might be interested in pursuing would be, or maybe how did this experience with this program, I guess, shape that prior interest that you had?
Yeah, so it really like opened my eyes to showing me how we can translate like neural signals, something that's like indecipherable, and we can use machine learning to translate them to actual specific motions. So, for example, we can use like, electron or electrode readings to say, okay, this person's trying to walk. Like that's super interesting to me. And I think like just how like mind-blowing that is, they can be used for so many different technologies like in the future, like prosthetic limbs. And that's what people are developing right now, prosthetic limbs, even like Neuralink and enhanced like intelligence. And I think just like in the future, there's so much innovation. And in college, I'll definitely be, continuing like research projects on that topic.
This is a very, very left field question, but I'll just put it out there. Do you have any
Mhm.
thoughts on the ethical dimensions of this kind of work? I mean, I think that you're describing these kind of radical, almost
Yeah.
transhumanist technologies that are on the horizon. Do you think that there
Yeah.
are any, I guess, what do you think the ethical implications of these, I guess, radical technological changes, occurring in the future and perhaps in a way that doesn't ensure equitable access?
Yeah, I mean, the ethical the ethical question is definitely like really important to figure out because not only is it like a privacy thing if we are giving like machine learning models access to our data or giving like some company like neural signals of who's trying to walk and where. That's obviously like, super dangerous and very invasive. So, I mean, I don't know like how it will shape out, but I think with this technology coming the next 20 years, I think like you're totally right. Like the privacy and the ethics of that is super important.
Yeah, like I said, very, very left field. I realize this is
Mhm.
not what you research, but it's interesting to me because I think that there's a tendency to see scientific research as kind of ethically neutral. It's just knowledge. Knowledge, it's just
Mhm.
facts, right? But I think that, with the intersection of, science and technology, facts are also power, and power has an ethical dimension. So it's just,
Yeah.
I think it's always interesting to consider how, um, I guess, research that contributes to radical technological change has is not simply ethically neutral.
Oh yeah, no, absolutely. Like if like it would be super detrimental if we gave, this technology like no reins. It's definitely important for there to be, you know, frameworks in place so that companies are not running around with people's neural signal data and having that would be catastrophic. So I mean I'm totally with you, like there's definitely like a need for ethics and laws in place so that this kind of stuff doesn't happen.
Yeah, I mean, I recognize it's a bit of a tangent. So going back to, I guess, the main topic, do you feel like the program has prepared you to do future research or encouraged you in your, I guess, prior interests in doing research?
Oh yeah, absolutely. I'm super happy with like how my program like shaped up. Like even writing the research paper, I didn't really have much experience writing any papers in the past, but my mentor who is experienced helped me, plan it out, write it, made it super simple for me. So I was able to like talk about, okay, here's my hypothesis, here's the evidence, here's why I think what I think is going on, and here's my argument. And he really helped me frame that very easily and helped me look for, journals and conferences to publish. And so I think that was super helpful. And it was honestly a really fun experience meeting with him like weekly. And I think that's something I want to like continue. I want to like it taught me I want to be part of like a project that solves a problem, in my years in university and beyond.
So just to clarify, have you finished your paper? You did send me a draft, so I guess
Yeah,
it's
yeah.
all wrapped up. Are you planning to publish it anywhere or take it to any conferences?
Yeah, still in the works of putting final touches. It's not completely done, but we're still putting final touches and gonna send it out in, a couple months, in the next few months. Yeah.
Great. Yeah, I mean it's really I think amazing to get early experience with publishing because I think that's one of the biggest hurdles that people deal with, like I guess in I guess building a career as a researcher or as an academic.
Mhm.
So I guess, do you have any other thoughts about maybe your overall experience? Is there anything that you wish you had known earlier? Is there any advice maybe that you would give someone who's going to do a similar program?
Yeah, honestly, like starting from the beginning, like the whole application, I remember, super simple. It was just like a personal statement, in terms of essays. And I was stressed at the beginning, but then I just wrote all my reasons to participate in the program, and I was accepted. So I think the thing is, if you're just transparent and like what you want to do in the program and why you want to do it, I think that's the best thing. And then even when it came to the interview, I was really stressed because I thought like my interviewer was going to ask me like technical, like leak code type of questions, but it was more of like a conversation like we're having today, and he actually cared, and I felt like he made an effort to know what my goals were with the program and match me with a mentor who, you know, thought alike and had similar interests and goals. So I think that was great because I think my mentor and me, we really got along, and we saw like eye to eye on how to solve different problems and where to go with our paper. So I think overall the experience with the application, the interview, and the mentor pairing was overall a pretty great experience from CCIR.
So, was there anything about the experience that you found unexpectedly challenging, or was there anything that maybe you anticipated being challenging that that was easier than you thought it would be?
Yeah, so I'm gonna come back to the interview because when I was preparing for the interview like a week before, they sent me like a whole document, and it was like sample questions. I was looking for the computer science sample questions, and it was all like super hard, super complicated stuff. Or not super complicated, but pretty difficult questions that we're like, okay, how do you reverse a stack from a queue or something like that? Like stuff that, I hadn't learned in school. So I was frantically trying to cover all the study guide stuff from the interview prep. But honestly, the interview was not bad at all. It was actually a math question. And most of it was actually like him trying to get to know me and my personal projects and how what I want to do with the research internship. So honestly, it was like a pretty positive experience. Nothing, to be too stressed about.
So, do you have any other final thoughts about, I guess, your experience and I guess what you took away from it?
Yeah, honestly, just super glad to have like my mentor because, he had a very good oversight of what this project could pan out. And he actually had very good domain knowledge. He's in the lab, and he provided me with a problem from the lab that we solved, and that's going to help the lab. So I think just having a mentor who's in the field, and I think that's like CCIR's big marketing point for the one-on-one mentorship. Having a mentor who's actually in the labs doing the work was super helpful for me, and is honestly like a great connection to have as well in later years. So just super happy with how it turned out.
Yeah, I'm glad it was such a positive experience. And I agree that, I mean, I guess I think science is a collaborative activity. So having that structure, being able to work sort of within the context of a lab through the program, I think is really great. I'm glad that you had that
Exactly.
experience.
Mhm.
Well, yeah, that's all the questions I have for you today. Thank you so much for sharing, your experience with us. And yeah, I enjoyed talking to you.
Yeah, thanks for having me. I'm super honored to be here.